Have you been thinking about how you're going to store all your supply chain artifacts? Hi, I'm Steve Lasker. I'm a PM architect in Azure, and I wanted to demonstrate some of the work we've been doing around how do you leverage registries, OCI Artifact registries, to be able to store new supply chain artifacts. First of all, why? Why would I put them here? Well, what we've seen with the artifacts work to begin with is we have these production assets, these assets that enable us from dev through production. They're highly available, highly performant, highly secure. Right? We're putting all these security capabilities on there, from RBAC to VNets to policy scanning and audit logs, double encryption at rest, geo-replication. Right? There's all of these things that we want to be able to do to have our content highly reliably, securely deployed. They're ubiquitous across all cloud providers and on-prem. Right? There's always a choice for what registry you would use. So we already have registries that can store images. Right? Now, we also have all these other artifact types that we want to be able to store. So what we saw in OCI Artifacts v1 was, why do we need yet another storage solution? Or please, not another YAS. The idea is that we can leverage these registries as artifact registries, and now we can pull and push all kinds of content to those using the same infrastructure we used for our images and across all of the deployments and security models that we have for those. And you can do it for the existing types as well. So what about these supply chain artifacts? First of all, what exactly are we talking about? So there's various SBOM formats out there. They're all boiled down to a file or a collection of files related to some other artifact. And that's kind of the point. From an OCI artifact registry, we don't care. It's just a set of files. You might want to push scan results into the registry so that they can also travel with your artifact. And there's various formats happening there as well. You might want to do your GPL source compliance and store the source code alongside the artifact. And of course, there's lots of other things that are coming up on a daily basis. The point is that I have some kind of artifact and I want to associate it with a target artifact. Now, what does this look like? So we're used to being able to do a Docker push of an image into a registry. Here we have our Acme Rockets registry. And the image has the config that has the architecture kind of information, and it's got a collection of ordinal layers. The ordinal layers are just blobs, and the configs are just blobs. So we basically have a way to do efficient storage from small to really large collections of files. I might want to sign that artifact. So what's a signature? It's another piece of content that we could store in a blob, but we want to say this signature is associated with, it is referenced to a subject manifest of the NetMonitor image. This thing is a signature that's associated with another artifact. I might want to push in SBOM. So I push in SBOM, has some contents of one or more files, and then I can associate it with the NetMonitor image. But the graph can continue. I can also push a signature on the SBOM because I want to make sure my SBOM's integrity is intact. So you can see this direct downward direction for the blobs that make up the artifact, and a new upward reference that says this thing is related to this other thing. Now, we kind of focus on a couple of principles here. First of all, multiple artifacts do exist, and we don't want yet another storage solution. No more YASs. We want to make sure they're alongside the target artifact. I have a NetMonitor image. Where is the SBOM for it? Do I have to go to some other URL? Where is that URL? Do I have access to that URL within this particular air-gap environment? We want to make sure they're associated with, but separable. I want to be able to get the SBOM without pulling the image. I want to be able to get the signature for the artifact to validate its integrity. I shouldn't pull the possible vulnerable image with all this bad runtime on it onto my machine just to find out it's actually not what I wanted. Right? That's the Trojan horse attack. And we want to make sure that we can add these reference types without changing the thing we're adding to. You have lots of deployment scripts that reference, some kind of image that is based on a tag or a digest. And we don't want any of those existing supply chain workflows to change. We don't want anything to do with Docker to change. We don't want anything to do with Kubernetes or Helm or anything to change. This is additional work. So that's great. Let's actually jump into some demos. So I've got a local instance of CNCF distribution running. And this actually has the reference types extensions that are added to it. So what I want to do is take a image that's available. So we're just going to do docker pull hello world. We'll do docker tag to our local registry, and then we'll say docker push hello world. So now I've got that in my local registry. In fact, if I were to list the catalogs, we can see the hello world repository is there, and we can see the evil latest tag is there as well. So I've got this one image and one tag in the registry. Now, if I look at the contents, I have a couple of sample contents that I want to use as supply chain artifacts. So I have a signature. It's just a goofy signature signed by Pat Doe for a hello world image. There's no specific format here that is implied. I have an SBOM, which the contents are good. I have a scan result, happens to be XML. All of these are associated supply chain artifacts that I want to add to my hello world image. And I'm going to push the SBOM to the hello world repo. Now I'm going to push it without a tag because this SBOM doesn't have value unto itself. It's a reference type to the hello world image. Its artifact type is example at SBOM. If I had my SBOM CLI, I wouldn't even just specify that. But I do want to specify what it's referencing. So here it's the local host hello world latest image. That's what I'm going to push this as with the ORAS command. So now that's there. But if I were to list the tags, you'll notice that there's no signature there. I can't see the signature. And that's intentional. We don't want to see the extra metadata. You want to know that there is a hello world image there, and you might want to know about some attributes of it. In this case, the attributes are the SBOM. So using the, what we've done is we've added a new refers API on the local registry. And now I can query the registry for the digest of the hello world tag. And notice that it just repeats the digest, and it gives me a collection of references back. And this is the manifest that got pushed. This is the artifact that went in that represents that SBOM. And you can see that the artifact type is a sample SBOM. And you can see that here is the SBOM itself stored in one of many collections of blobs. And you can see that it references back the hello world image. That's pushed in, and it's indexed, and the refers API can bring it back. Now, I don't want to have to do curl every time, so we've kind of been doing this investment with ORAS, so you can see that the ORAS command brings back the same thing. Give me back the references, discover, for the local host hello world latest image. Now, I might want to put some more information into the registry related to the hello world image. So here I'm going to push a signature. I'm referencing the hello world latest image. It's going to the hello world repo, and I'm pulling in the signature JSON file. So now, if I do ORAS discover, we'll see two things that got added. We see the SBOM we pushed first, and now we see the signature that got pushed as well. So I'm able to push a collection of things related to it. And I can continue to do that endlessly. I might want to get them all, or I might want to get back a specific artifact. So what we're doing here is we're saying ORAS discover, but filter on the artifact type of signatures. So now you'll see that I'm only bringing back, see there's only one here, I'm only bringing back the signature type. And if I was using something like Notary, I can filter further on maybe an annotation for a specific signature that I'm looking for. The idea here is that I can get what particular information I'm interested without having to query the registry for all the blobs when I know I only care about one or a few of the overall reference types in the registry. So that's great. I can discover them. How do I pull them? So to pull them, we can use the ORAS pull command. The only difference here is it's because the reference type is stored as a digest, there's no tag, we have to go find it, which I can use the ORAS discover command. So I can say ORAS pull, but notice when it goes to pull the digest, I embed in here to say, hey, ORAS discover, find me the signature types for the hello world image, and in this case, I'm just cheating and pulling the first one out of there. I could use the notary client if I wanted to be smarter, but the idea is you can see through the netmonitor image. The target artifact is the thing I'm kind of thinking about. Now I've downloaded it. I can see the signature, and I can now see that I've got my Papto signature for that particular hello world image. So that kind of gives you a quick demo and context of what we've been thinking about with reference types. The idea is that we want to make sure that these things are holistically stored in a registry in a very understandable way. It's important for these things to not just show up as a list of tags, because it's the only way we can reference things without them getting automatically deleted, because I don't really want to see that noise. What I really want to see is my list of images, maybe there's signatures, maybe some of them have SBOMs, maybe some of them have some metadata on them. I want to see these reference types as additional information, not noisy up my whole listing. And that's what I think about those with lifecycle management as well. If these things, all of these objects were individual objects in the registry without the registry knowing their relationship, how would we manage any kind of lifecycle or content management? So the idea is because these things have relationships to each other, we can create a graph around how these things are stored. We can start to do interesting things like copy stuff across a registry. We know how to copy an image and the layers and the config because that's defined by a manifest. Because we have these reference types now that can define relationships between manifests, I can actually create another OCI reg command that would copy the graph of artifacts across as well. And because they're in the other registry, I can put them into a VNet environment that has no public access, so it's kind of air gapped, and my cluster can get access to those artifacts and so forth. So that's awesome. And of course, you can do other things like include specific references or copy, without references, right? Once you have this rich metadata about the type, that graph, the type of objects you have, you can start to do interesting things with the metadata to figure out how you want to copy it across. And one of the interesting parts is how do you manage the life cycle? What if I want to delete the netmonitor image? Don't I want all of those other things to go away as well? Because all of those collections of signatures and SBOMs and their signatures and the YATs that hang off those, all of that stuff should go away when I delete the netmonitor image. I don't want all these zombied objects left behind. So that's a quick status on where we're at. The artifacts references are reference types. We have in a PR. We've implemented it with ORAS, as you saw, to push, discover, pull artifacts of a CNCF distribution implementation, so that you don't have to test this within Azure or someplace else. You can run it locally. And then, of course, this will show up with Notary, and we'll be able to start shipping these in our cloud providers, enabling you to use reference types to store supply chain artifacts in your environment. So, thanks for watching.